Okay, so let us get going with our lesson, guys. Okay, we are going to be looking today at whole numbers. So we're starting off with the number system and whole numbers, okay? And we are first of all going to look at whole numbers. But before we get there, let's look at the different number system and why and where numbers fall and where whole numbers fall. So if you look at this block that's at the top here, it's a really nice representation and something that you can use to remember where all these different words come from. So again, like I said to you, screenshots encouraged. Go back in the chat. I've put some instructions there for you. If you're not sure how to use screenshots on either your Windows computer or your Mac device, your MacBook, they're there in the chat for you. If you're using your phone, I'm sure you all know how to use screenshots quite well, but there they are in the chat. Okay, so we're looking at whole numbers this term, and whole numbers sits here. Okay, now, when we first start learning how to count, okay, think about when you first started learning how to count and you were climbing the stairs or you were, I don't know, walking along the pathways or anything like that. The number that comes naturally to you, the first number that you learn about is the number 1, 2, 3, 4. Those are your natural numbers, the ones that come naturally. Okay, so we always start with our natural numbers and the natural number system. So natural numbers start with the number 1, 2, 3. Now, guys, why is it important that we know the distinction between all these different number systems or the different names between these systems? Teachers like to give us things like multiple choice questions on this. It's a very popular multiple choice question or a match the column question, okay? So we're going to see questions like this in our tests, and we're going to see questions like this in our exams as well. So we start with our natural numbers, 1, 2, 3, what comes naturally. Then we move on and we go to school, and we talked about the number 0. We're told that 0 has nothing. It's not worth any value, all right? And in our number system, we call that part of the whole number system. Now, the way that I remember that whole numbers contain the number 0 is that, have a look at the word whole. Whole has a 0 contained in it. Okay, so natural numbers, it's natural to start counting from number 1, all right? Exactly, Lorona, they are any positive numbers. They're not decimals, they're not fractions. Good, because that's not natural when you first start counting. Whole numbers start at the number 0, 0, 1, 2, 3, 4. Also, don't have any decimals, don't have any fractions. And then when we get to grade 7, like we learned about last year, and we spent quite a bit of time on if you were here with Toby, and even in your classes at school, you would have learned about integers. Integers, what were integers, guys? Who can tell us in the chat? Who can remember? We did really nice definitions on integers. Who can remember? Who wants to tell me? Who can remember? Who's got their definitions on them from last year? Mars saying negative numbers. Good. Okay, Lorona. Yeah, it includes negative numbers. Who else? Who can remember last year? Good, Lufano. Negatives and positives. Good. So integers are negative numbers, the number 0, and positive numbers. Remember, integers are the ones that they always catch us on because we're always so quick to go, integers are negative numbers. Integers are lovely, Itandile, a set of negative and positive numbers. Well done. All right. Now that we're in grade 8, okay, this year in grade 8, we're going to move on from that. And this is like a forthcoming attraction. Okay, so like, you know, in the movies when like the little previews before you actually get to the movie, all right? This year, we're going to learn about rational numbers and we're going to learn about irrational numbers. So these are all forthcoming attractions here. So a rational number is a number that can be made into a fraction. Any number that can be made into a fraction Okay? So that's the short definition of a rational number, any number that can be made into a fraction. And we're going to spend a bit of time on that a little bit later in the year. And when we look at irrational numbers are numbers that they could be made into fractions. However, okay, they're going to leave us with long decimals. So they're going to be things like the square root of 10. When you put the square root of 10 on your calculator, what happens? You're going to get long decimals, okay? And they're not recurring decimals. They're decimals that give you many different figures going off into infinity. All right. So for example, 1 comma 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, going off into infinity. Okay. The square root of 3, if you put that onto your fancy new calculators that you've got for grade 8 and you press equal, it's going to give you a very long number with lots and lots of decimals. All right. So the first bit that we're going to look at, all right, today, as part of our whole numbers, is we're going to look at prime numbers. Okay, so while you're taking down that definition, I'm just going to have a look. Brianna saying to me, is pi a rational number? So Brianna, pi is actually not, it's an irrational number. Because if you put pi into your calculator and you press equals, you're going to see that it gives you many different decimals. And people actually, there's a special day, it's called Pi Day. All right, they actually learn all those little decimals and there's competitions to see who can actually learn the most of them. So no, pi is actually an irrational number. Okay, so let's start with our prime numbers because this is the one we're going to be working with a lot this term. Prime numbers, part of the whole number system, they are numbers with only 2 factors. Okay, very important. Prime numbers have 2 factors, all right? They have the number 1 and itself. So a prime number is any number where it can have 2 factors, the number 1 and itself. On your screen, you'll see that the 8 numbers from 1 to 20, which are prime, are the number 2. Why is the number 2 prime? Because what can go into 2? 1 can go into 2 and 2 can go into 2. 3, 1 can go into 3 and 3 can go into 3. 5, 7, 11, etc. But why not the number 1? All right, why is the number 1 not prime? And that's one of the best questions that they can ask you. And when you do this in class, you can even tell your teacher, why is the number 1 not prime? Number 1 is not prime, why not? Because to be prime, you have to have 2 factors, okay? So for the number 1, how many factors or what goes into the number 1? All right, what goes into 1? The only factor of 1, only thing that can be divided into 1 is the number 1. So how many factors does 1 have? It only has 1 factor. Well done, Ma. So the number 1 is not prime. Right. Write out the definition, take a screenshot of it, whichever one you want to do. If you didn't get to write it out, I am going to leave you a bit of space on the screen. Let's have a look at practicing the kind of questions that you're going to get this year in grade 8. So you might have learned about prime numbers last year in grade 7. Amazing. If this is a little bit of revision for you, great. Let's have a look at some questions you'll get in grade 8 now. So our question says to us, number 1. Write prime numbers between 40 and 80. So last year in grade 7, they might have given you questions that were really nice and easy. Maybe they asked you the prime numbers between 1 and 20, and those were nice. We know what those are, okay? Now they're asking you, write the prime numbers between 40 and 80. Now, my grade 8 class, I'm giving you 2 minutes to go try it. I want you to think about it between 40 and 80, right? You're looking for numbers where they only have 2 factors. The number 1 can go into it, and it can only go into itself. Go give it a try. Go give it a try. I'm giving you 2 minutes to go give it a try. Prime numbers between 40 and 80. Go give it a try. Got this. Okay, I'm seeing some screens on today. That's fantastic. I can see you guys working. You know, I always love that. All right, welcome to those grade 8s who've joined us a little bit later. It's so nice to see you all. So nice to have you in class, everybody. Oh, Amar has got the answer for me already. Amar, we're going to give everybody 1 minute, and then you are giving me your answer, Amar. Well done. Oh, it's Andile also on fire. Well done. Okay, you got a few minutes or a few seconds, sorry. Few seconds left. Okay. Oh, Lejo's sending me the answers. Well done, Lejo. I like that you sent them to me. Well done. Thank you so much. Okay, let's have a look. So, Umar, you had your hand up first. Do you want to go ahead and give me your answers? Let's have a look.
Yes, ma'am.
Hi, how are you, Umar?
I'm okay, and you?
Good. Are you glad that classes have started again?
Yes.
Ah, good. We missed you. Okay, let's go, Umar. Give me your answers. What did you have?
41, 43,
41. Good. 43. Great.
47,
Amazing. Good. So far, you are on track with Lejo. Okay, carry on. Let's go.
53,
Awesome. Good.
59,
59. I like it. Good. Carry on.
61,
Yes. Good.
67,
Great.
71,
That's it.
73,
Great.
and 79.
Amazing. Well done, Umar. Fantastic. And you were quick. Well done. Have you been doing this in class yet?
Yes, we were forced to learn it off by heart.
Forced to learn them off by heart. Okay, good. But look how well you did. Well done, Umar. Thank you so much.
No problem.
All right. Okay. Everybody agree with Amar? You can give me a thumbs up on your reactions if you agree with Amar, or you can give me a thumbs up in the chat. Good. I'm liking it. Good. Okay, so Lorena's asking a really good question. Lorena's asking, ma'am, we were supposed to name more than one. So make sure that you're checking how the question's asked, okay? So if we look at how the question's asked, it says, write the prime numbers between 40 and 80. Okay, so it's asking you to write all the prime numbers between 40 and 80, which means it wants more than one. Okay. Then somebody's asked me as well. They said, ma'am, what about 47? Is 47 not a prime number? Does 7 not go into 47? Guys, check. Go pull out your calculators or go do some long division and check. Or go do it on your hands. 7, 14, 21, 28, 35, 42, 49. So 7 definitely doesn't go into 47. Okay, I'm happy with Umar's. Good, I'm seeing lots of thumbs up. Right, let's move on to the next question. Okay. My next question says, write down the numbers from the list below that are prime numbers. Okay. Write down the numbers from the list below that are prime numbers. Go give that a try. In the meantime, so ma'am, if they ask for one prime number, how do we know which is it? So they're not going to ask you in grade 8 for just one prime number. They're going to ask you for the list of prime numbers or to name all the prime numbers. If they're just asking you for one prime number between those, then you could name a whole lot of different ones, which gives teachers a whole lot of options. It's not really the kind of question they're going to ask you in grade 8. Okay. So they normally ask you for all the prime numbers between 40 and 80. All right, Bree, I hope that makes sense. Okay, write down the numbers from the list below that are prime numbers, guys. 1 more minute. I've got hands up already. Fantastic. All right. Nice. Okay, so I am going to go with Bushle. Bushle had their hand up first. Bushle, hello.
Hello.
Bushle, how are you?
Fine.
Good. Did you miss having extra lessons?
Yes, I did.
Oh, we missed you as well. Okay, Bushle, talk to me. Give me the prime numbers, please.
3,
3, good. Well done.
5,
Okay, so we're saying 3, good. Nope, nope, nope. 5, good.
13,
13, well done.
and 67.
And 67, cool. Thanks, Bushle. All right, does everyone agree with you? I'm just going to check with Itandile if Itandile agrees. Hi, Itandile. Itandile, do you want to unmute? Oh. Okay, I'm not sure why Itandile can't unmute. Lorona, do you want to unmute? Do you agree with Bushle?
Yes, I do agree.
You agree? Okay, you don't.
There's nothing, I think, there's nothing more.
Okay, cool. Thank you, Lorona. All right, Bushle, I'm going to come back to you. Can you hear me, Bushle?
Yes, ma'am.
Okay, let's go. Bushle, what about 37? Talk to me about 37. Can one go into 37?
Yes.
Can anything else go into 37?
No.
No. So is 37 a prime number?
Yes.
Ah, okay. So 37. All right. 49, no. Hey, 49, 7 can go into 49. Do you agree? So that one, I agree with you. That one's not a prime number. 77?
No.
No, because 7 can go in there, hey?
Yes.
84?
Nope.
Nope. What about 91? Let's think about 91. What can go into 91? 91, can everything go into 91? Let's think. Anything else? There's your sister next to
9.
you. That's okay. Hello. All right. Anyone else? Somebody saying to me in the chat, but I'm happy to have a look. What about 7? I think 7 and 13. So that one? Nope. Hey, so Bushle, the only one we left out was 37. Hey, do you agree?
Yes.
Okay, thanks, Bushle. All right. Okay, guys, let's move on. Thank you so much for those people that put their hands up. Amazing. All right. So we've had a look at our number systems, okay? We had a look at what they look like. We've had a look at prime numbers now, so we've done a little bit of revision on that. Now we're going to move on, and I want to remind you about something that we learned last year, okay? It was something that I reminded my classes about when we had extra lessons together. If you're new to classes, that's all good, all right? I want to remind you about this special little word, okay, before we move on to this next section. And that special little word is the following. It is BODMAS. All right. Who wants to tell me what BODMAS means? We did quite a bit of it last year. We spoke about BODMAS. Okay, who wants to speak to me about BODMAS? Brianna. Hi, Brianna.
Hi, ma'am.
How are you?
I'm good and you, ma'am.
I'm good, thanks, Brianna. Brianna, talk to us. What does BODMAS mean? Can you remember? What does B stand for?
B stands for brackets.
Good. And what does it mean, though? What does it mean when we've got BODMAS?
I think it helps us to calculate which one is first.
Good. So which one is first? Good. So when we're doing the order of things, hey, do you agree?
Yes, ma'am.
Okay, good. So when we're putting things into order, that's what we're looking for, hey? We're looking at BODMAS. Good. So B stands for brackets. I'm happy. I like it. Good. Well done. All right. So no. Okay. Let's go make some space here. All right. B stands for, let's go here. So we've got BODMAS. I think we got a bit distracted because our screen was playing up again there. We've got BODMAS. Right, stay with me. So B was for brackets.
Yes, ma'am.
Can you remember what my favorite color was? What pen am I going to write in, Brianna? Can you remember?
Is it purple?
Oh, well done. Okay, so B, brackets. So if I see brackets in my sum, I'm going to do the brackets first. Hey, well
Brackets
done.
first.
Okay. What does the O stand for? Can you remember what the O stands for?
Of.
Of, good. So of. And now that we're in grade 8, some teachers like to call it orders. Okay, so of to the power of something or the order. So it's the of, hey, the exponents. Well done. Okay. What does our D stand for?
Division.
Division. Good. So if I have a sum, it's got brackets. I do the brackets first. Then I do, if it's got of, I do the of. Division, then
Multiplication.
nice. You're on fire today. I was worried you guys were going to be too tired for my lesson, but well done. Multiplication. Then we move to the A. What's the A for?
Addition.
Addition. And the S is for?
Subtraction.
Subtraction. Now, if you guys go and you join the Google Classroom tonight, I'm going to put the most annoying song, Brianna, onto Google Classroom for you guys from YouTube. And you are never, ever, ever going to forget BODMAS. All right, it's going to be stuck in your head forever. Okay, so remind all your friends who are part of Maths Live, they need to go, they need to join Maths Classroom, Google Classroom, because on there is going to be the most annoying song, but it's going to make sure that you guys never, ever forget BODMAS, hey? Do you agree, Brianna?
Yes, ma'am.
Very important.
Yes, ma'am.
Okay, have you joined the classroom yet?
I have, ma'am.
Fantastic, good. Everybody should join, am I right?
Yes, ma'am.
Okay, thanks, Brianna. All right, so guys, the most important things we still need to remember about numbers, whether it's whole numbers, whether it's about integers, whether it's we're looking at natural numbers, is that we must always remember BODMAS, must always be playing in our minds. So now that we've had a look at our what our whole numbers are, what natural numbers are, we've looked at prime numbers. Now we're going to start looking at the basics of our maths. We're going back a little bit into grade 7, going back into our basics, but we're going to put some very fancy grade 8 words to this. All right. And the first fancy grade 8 word that we're going to learn here, okay, is cumulative law. All right. So we're going to learn about the cumulative law first in grade 8. All right. It's a very fancy word, but it just means to add. So changing the order in which we add, subtract, multiply, or divide groups is called the cumulative law. So that's what we're learning about first. It's still very basic maths. I promise you, it's just a very fancy name. So I promise you that today we were looking at all our basics, and that's exactly what we're doing. The order in which we add groups of numbers does not actually matter. So if we've got a group, we've got numbers and they've all got addition in it, it doesn't matter what order we add them in. as long as we add them all. The answer is the same no matter which way we add the numbers. The cumulative law holds for addition. So when we're looking at addition, cumulative law holds. However, all right, what is the law that is the most important law? Always, always, always. Tell me in the chat. What did we just look at? What's the most important number one rule? I always say it. I'm going to put the annoying video onto YouTube for you to go and watch. What is it? What's the thing that holds true no matter what? No matter if you've got cumulative law, distribute, all these fancy ones. Good. BODMAS. Good, guys. Well done. BODMAS is going to play a role no matter. That is the number one rule. Okay. However, what this is saying to you, okay, so that's why I don't want you to get confused. That's why we looked at BODMAS, is that if you've got a whole group of numbers and you're just adding them, it means that you can do them in a different order. Okay. So if we're looking at this first row of numbers, we've got to be very careful here. We've got to read them carefully. It says to us 3.1. We've got 60 plus 7 plus 13. B, we have 7 plus 13 plus 60. And C, we have 60 minus 13 plus 7. I'm going to go and I'll leave those three for you at first. I want you to have a look at that. Okay, 3 nice, easy numbers. Remember last year in grade 7 when they started giving you crazy numbers to add? We're not doing that today. We're starting with some nice, easy ones. All right. Go and have a look. What's the easy way for you to add those? Okay, good. Moringi saying by using BODMAS. I agree. Absolutely. Okay. All right. Let's start with A. Okay. So for A, promise I'm going to make the screen a bit bigger. I just want to copy the question across. I've got 60 plus 7 plus 13. So if that's my question, right, what this is saying to you, okay, and I love what Brianna is saying, all right, for me, when I'm looking at this, the easiest thing for me to start with is I would leave the 60 where he is for now. Because I know that what's going to happen when I say 7 plus 3 or 7 plus 13, actually, if I start by adding just these two numbers here, guys, 7 plus 13, all right, 7 plus 13, that's a really nice, easy one for me. 7 plus 13 is going to give me 20. And 60 plus 20 gives me 18. So that's what cumulative law is. It's saying to you, you don't have to do the sum in the order that it comes in. You can change the order around as long as, all right, as long as whatever is sitting before this number. So do you see this 13? What's sitting before this 13? There's a plus. Do you see the 7? What's sitting before the 7? There's a plus. And actually, for this number 60, what's actually sitting before this number 60? Is it a positive 60 or is it a negative 60? You tell me. Is this 60, is it a positive 60 or is it a negative 60, guys? Tell me in the chat. Good, Moringi, it's a positive 60. Okay, so in other words, if I had to go and I had to look at the next sum is 7 plus 16 plus, 7 plus 13 plus 60. So for the next one, the sum now looks like this. It's B, 7 plus 13 plus 60. So what have they actually just done for B? They just moved the sums around. Lorena, you are absolutely right. It's positive because there's no negative symbol before it. So because there's no negative sign before it, it's automatically a positive. And you can shuffle that sum around until it makes more sense to you. Now, this might not seem like it's an important thing now at the beginning of the year, but later on, when we start bringing in A's and B's and X's and Y's, this is going to be so important. So remember this for later on. Okay. So again, I can say 7 plus 13. That gives me 20 plus 60. And I get 80. All right. Now, let's have a look at C. So for C was 60 minus 13 plus 7. 60 minus 13 plus 7. Now I need to be a little bit careful. Okay, now I need to be a little bit careful with my cumulative law because now I've still got plus 7, so that's still fine. Okay, but now what's happened? Now this has become minus 13. Okay, so good. I can still do my BODMAS. I like it, Lorena. So that's what I'm going to go do. I agree with Lorena. I'm going to go do some BODMAS here. I'm going to say, I'm going to shuffle my sum around. I'm going to say 60 plus 7, and I'm going to move my minus 13. Am I allowed to do that, guys? Of course I can. Okay, of course I can. I can shuffle that sum around as much as I want to, as long as I keep all the symbols with their numbers. So 60 plus 7 is 67. Minus 13 gives me, whoopsie, 54. Okay. All right. So it just takes it from being so difficult. Oh my gosh, now we do it in order. You don't have to do it in order. You can shuffle it around. Cumulative law. Accumulate all the like symbols together or the ones that you want to add together. All right. I'm going to bring those questions back up for you. So for the next row, 3.2, A, B, and C are exactly the same. Okay, so you only have to write the sum out once. They've just written it out in different ways for you so that you can see it. I want you to go and add for me, whichever way makes more sense for you. And then you've got a multiplication one to try. And there's a challenge for you in the last one. Go have a try, guys. Go have a try with those. Go see. So I can tell you 3.2, they are all exactly the same. So I'm giving you that one. 3.3 is all exactly the same. 3.4, there's a challenge for you. Okay, go give those a try for me. Go give it a try. I'm giving you, let's say 5 minutes. I'm giving you a try. And even if you don't finish them in 5 minutes, that's okay. I just want you to go give it a try. All right, so again, you can move stuff around, you can shuffle it, you can do whatever you want. Go give it a try. All right. I'm loving seeing 23 of you in our first class. Well done, grade 8s. Okay, well done. Hey, if anyone has any questions about some of the other work we've done, you're more than welcome to ask now. Right. Brianna, do you have a question for me?
Ma'am, I have a question when we are writing an assignment.
Sure.
So let's say the teacher gives you like 7 plus 13 plus 60.
Mhm.
And you did the sum right, but the answer is wrong. Will you get 0?
So, Brianna, if you've shown you're working, okay, so if you've shown how you worked it out, so you know, like the steps that we've just done, then
Yes,
you'll
ma'am.
get what they call, I think we did it, I think I did it with the grade 9s last year. I didn't do it with you guys. You get in grade 8s now in high school, you get these things called method marks. So it's really important. Remember, like in grade 7, you guys used to do lots of like mental maths and trying to do it without showing your calculator, like those kind of work. In grade 8, it's really important that you show as much working as possible because the teacher can give you marks just to show your workings. Does that make sense? So even if your
Yes,
answer is
ma'am.
wrong, she can still give you marks for your workings all the way through. And that's a really hard thing to like wrap your head around because in grade 7 you didn't have to show a lot of working. Am I right?
Yes, ma'am.
You just had to get your answer right. But now in grade 8, you have to show your working. So yes, you can still get marks even if your answer's wrong. Yes.
Okay,
Yes.
thank you, ma'am.
Okay. Thanks, Brianna. All right. Anybody else have any other questions, guys? Anyone have questions about maths as a whole at high school or want to ask me any other questions? Maybe you've had a question in class this week while you're busy doing these questions. Quick, we got 1 more minute for people trying to do the sums on the screen. Nothing. We're so quiet today. Sure. Oh, nice quiet class. My goodness. Doesn't feel like my old grade 7s here at all. Think it's been a long week, obviously, here. And it's only Tuesday. All right. Let's have a look. So, Lejo, I'm so sorry. You did send them to me privately, but my mistake, you put them on the chat. I see that. Don't stress. That's okay. So, Lejo did help us out. Lejo put the first answer for us on the chat. So, I'm going to ask Itandile, because Itandile's got their hand up. I'm going to ask Itandile if Itandile wants to help me out. Hi, Itandile.
Hi, ma'am.
How are you?
I'm fine, thank you. How are you?
I'm good. Right. Itandile, talk to me. How did you find, what was the easiest way that you found that sum to do the next one?
It was easy, ma'am.
Was it easy? Okay. Which one was the easiest way for you? A, B, or C? So which one was easier? Was it easier to say 10 plus 11 plus 20 or 20 plus, or was it just easy either way?
Easy all of the way.
Okay, let's go. So we've got 20 plus 11 plus 10, but we're in grade 8 now, so we want to show all our working, hey? So
Yes,
20, I'm going to go 20 plus 10 gives me 30.
30 plus 11, which gives you 41.
Nice. Okay, let's do the next one. So
So
which one was easier for you?
it was when I said 20 plus 11 plus 10.
Okay, cool. And for 3.3, which one was easier for you? A, B, or C?
C.
C. 4 times
Yes.
3 times 6. Okay.
Yes.
So Itandile is saying she did this one. She did. I'm going to go here. 4 times 3 times 6, hey?
Yes, ma'am.
Okay, so Itandile, do you agree that they're all the same? 4?
They're all the same, ma'am.
Good. All right, talk to me. 4 times 3, what do you get?
4 times 3, I got 12.
Good.
Then I times it by 6, which gave me 72, like A and B.
So 12 times 6 gave you 70.
2.
Nice. And if you do the exact same thing to the others, you also get 72. Why?
2.
Because it's all multiplication. Well done, Itandile. Great. Okay, now, what did you notice that was different about 3.4?
Ma'am, it's because of all the answers are not the same.
Good. All the answers aren't the same. And why not? Because all the symbols are different. Am I right?
Yes, ma'am.
Okay. So let's go do the first one. All right. I've got 50 divided by 2 plus 6. So,
So, ma'am, what I did, I shifted.
Yep.
I shifted divided by 2, and I put it after when I said 50 plus 6 divided by 2, I shifted, which gave me 56. Then I divided by 2, which gave me 28.
Now, Itandile, I would agree with you with that normally, okay? Because cumulative law tells me that. I agree with you. Cumulative law says I can do that. If
Yes,
it
ma'am.
was plus or minus signs, hey?
Yes, ma'am.
However, what have I got in there, Itandile?
You got a division and a
So is it different?
yes, ma'am.
So what now applies? What applies if there's a division sign in there all of a sudden? What must I use?
You should use body mass.
Very good. Well done. So if I had plus and minus, can I move it around? Does cumulative law let me move it around with plus and minus signs?
Yes, ma'am.
Yes, but if it's got a division sign, what happens? I must stop and I must use cumulative, I must use BODMAS, eh? So
Yes,
what does
ma'am.
BODMAS say? Brackets. Is there any brackets?
No, ma'am.
Of?
No, ma'am.
Divide?
Yes, ma'am, there is.
Okay. 50 divided by 2. I'm going to help you out. It's what?
It's
25
Yes, ma'am.
plus 6.
6.
25 plus 6 is?
31. Sorry.
31. Well done. Okay, can you see how it gives you a different answer, hey?
Yes, ma'am.
Okay, so you have to be really careful. All right, let's do the next one together. All right, so the next one says 50 times 2 plus 6. So 50 times 2 plus 6. Are all the signs the same?
No, ma'am.
No. What's the difference here?
There's a multiplication sign.
There's a multiplication and a plus. So, oh, got a problem. Am I right?
Yes, ma'am.
Okay, so what have I got to say now?
Ma'am, you're gonna say now. So you're gonna apply division, body mass, which gives there's no bracket, there's
Good.
no there's no division, which is multiplication. Then
Good.
you're gonna
So,
say 50 times 2, which is 100, plus 6
good.
is 106.
Amazing. Well done. All right. And let's go the last one.
Ma'am, the last one was since there is still a multiplication sign, I started with addition. I started with multiplication first, which was 2 times
Good.
6, which was 12.
Good.
Then I said 12 plus 50, which
Which
gave me
is
62.
amazing. Okay, guys, do not get caught out. Be careful, Itandile. And if you've got those new fancy calculators, let's say your school made you buy those new fancy calculators, those scientific ones, those ones also don't always realize that there's BODMAS. So they also sometimes mess up. So just be careful, okay? All right. Thank you so much, Itandile, for helping me out. Okay, so that is our cumulative law where we're allowed to move things around if all the signs are the same or if we've got plus or minus signs, guys. But we need to be careful where we've got different signs in there. So if there's plus and add or divide and add or divide and minus, then we must use BODMAS. All right. When we calculate numbers, we work with two numbers at a time. If we change the pairing in which we calculate pairs of numbers and the numbers remain the same, this is called associative law. So when we change the way that things move around, the fancy name for that is called associative law. You might have heard it in class before. The way we pair numbers which are being added or multiplied does not matter. The answer is the same no matter which pair of numbers we calculate first. So, very similar to what we were doing before, okay? Here again is a list of numbers. We're not going to go through all of them. We're going to have a look, right? But if we look at the numbers that they've given us, right, we've got the same sum 3 times over. So for the first one, we've got 15 plus 7 plus 8. So let's do the first one together. So if I say 15 plus 7, 15 plus 7 gives me 22, and 22 plus 8 gives me 30. But if I do it a different way around, if I say 7 plus 8, 7 plus 8 gives me 15, and 15 plus 15 could give me 30. And again, if I do it a whole other way around, if I say 15 plus 8 gives me 23, and 23 plus 7 gives me 30. So when you've got 3 sets of numbers, you can only work with 2 at a time when you're adding or subtracting. So that's what it's saying to you there. Okay. So in these sums, what's different about these sums and the ones we looked at before? You'll see they all have addition sums or they all have multiplication sums. All right, take a screenshot. You can go back. You can practice these at another time. All right. Now, we have 2 minutes left, okay, on our lesson on Thursday. All right, we're going to be carrying on and we're going to finish this up on Thursday night. Okay, so we're going to finish up our few little things that we've got to finish up on Thursday night. All right, and then we're going to be moving on to HCF and LCM. Prime factors, our factor trees, all those exciting things. So make sure you come back on Thursday because that is what you're going to be learning. It's all brand new stuff to grade 8. Guys, a reminder